Okay, in this presentation we're going to look at the negative binomial distribution and how we can characterize the negative binomial distribution as a member of the AB0 family of probability distributions. Now, characterizing it as such helps us to use some of the properties of the AB0 family of distributions that help us sort of speed up calculations essentially so that we don't have to do everything from scratch. So anyway, we have a random variable x here that follows a negative binomial distribution, and we're giving the following pieces of information. We are told that the expected value of x is 3. Okay, we're told that the probability of x equal to 0 equals 4 over 25, and then we are told that the probability of x equal to 1 is 24 over 125. So we're asked to do two things: calculate the probability of x equal to 2 and then x equal to 3. Okay, so a discrete probability distribution that satisfies the following recursive relationship is said to be a member of the AB0 class of probability distributions. So the probability of k divided by the probability of k minus 1, so that is essentially p0 and p1. So that's, we could characterize that as follows, like p1 being pk and pk minus 1 being probability of 0, essentially. So they're successive integers. Okay? Now, so the ratio can be specified in terms of two values, a and b, as well as k as well, that particular integer. So if the negative binomial distribution is a member of the AB0 class of distributions, so that is the probability mass function. Now we're not going to get into it too much here. So, but just as a quick remark, A is 1 minus P, which is the parameters of the negative binomial distribution, and the other parameters here is written as alpha, and B is actually alpha minus 1 times 1 minus P. Okay? So that's how the A and B would correspond to the parameters that we would be looking for, or how we specify the negative binomial distribution. Now, it's also worth noting that with the initial probability, p0 equals p to the power of alpha, and that the mean is, in terms of alpha and p, is alpha times 1 minus p times p. Now, just as a quick remark, there are multiple ways of specifying the negative binomial distribution. We're using one particular format here, but other presentations, particularly with the Poisson gamma mixtures, there's slight differences to the way we do things. So just watch out for that, okay? So we're given two values for probabilities, p1 and p0, which is probability x equal to 1 and the probability of x equal to 0. So that is, probability of 0 is 4 over 25, and the probability of 1 is 24 over 125. So if you just work that out as a ratio, that should work out to be 24 divided by 20, which is 1.2. Now that is A plus B divided by K, where K corresponds to the integer corresponding to the probability up above this line. Okay, so K is equal to 1, and therefore A plus B divided by K is simply A plus B. So 1.2 is equal to A plus B. Okay. Recall that we have expressions for A and B denominated in terms of P and alpha, the negative binomial parameters. So A is 1 minus P, okay, and B is alpha minus 1 times 1 minus P. So A plus B is essentially adding those two numbers together. We would actually sort of, those two expressions together, we would get alpha times 1 minus P, and that is equal to 1.2 using what we have learned up here. Okay, now the expected value of x is 3. So E of x is 3, and this is equal to alpha times 1 minus p divided by p, according to our formulation that we're using for the negative binomial distribution. So we actually already have an expression for alpha times 1 minus p already there. But yeah, just sort of like, we'll cross multiply it anyway. So 3p equals alpha times 1 minus p. And you can sort of see this is resolving itself very quickly. Combining both identities, 3p equals 1.2, that means p equals 0.4, and then we can come up with an expression for alpha, okay, which is 1.2 equals 0.6 alpha, so alpha equals 2, okay. So we don't really need values for a and b. Well, we can find them out. A equals 1 minus p times a equals 1 minus p equals 0.6, and b equals alpha minus 1 times 1 minus p, which is 2 minus 1 times 0.6, which is also 0.6. And again, recalling that they add up to 1.2. Okay? So, what we're asked for is probability of x equal to 2 and the probability of x equal to 3. Sorry, we actually do need a and b for this. So we know what x equal to 1 is. We're given that previously. What we have to do is find the probability x equal to 2. And in this case, that is equal to k is equal to 2. And therefore, we're dealing with a plus b divided by 2. And that is 0.9. So the ratio of x, probability of x equal to 2 and probability of x equal to 1 is 0.9. We know that probability of x equal to 1 is 24 divided by 125. So multiply that by 0.9. And working it out, we should get a fraction like 108 divided by 625. Calculating the probability of x equal to 3. K is equal to 3. And a plus b divided by k is a plus b divided by 3. So that's 0.6 plus 0.6 divided by 3. That's 0.8. So it is cross-multiplying. The probability of x equal to 3 equals 0.8 times the probability of x equal to 2. Little bit of calculator work and we can come up with an expression there like that. 423 divided by 3,125. Okay, you can come up with real number expressions there, but the fractions work because we're given some probabilities previously in terms of fractions. So that's it, yeah.